Let's solve a few problems involving sequences. So the first problem is write the first four terms of the sequence a sub n when n goes from 1 to infinity. This is how we read this. For the following problem, a sub n equals 1 over 10 to the n. So n goes from 1 to infinity, but n is natural numbers. So we don't have n 1.5. We have a sub 1, like the first term, a sub 2, a sub 3, a sub 4. This is how many we need to find. So a sub 1 means in 1 over 10 to the n is going to be 1. So we get 1 over 10. A sub 2, it's 1 over 10 to the second, so it's 1 over 100. A sub 3, it's 1 over 10 to the third, so it's 1 over 1000. And a sub 4, it's 1 over 10 to the fourth, so it's 1 over 10,000. Let's take another look at this problem. A sub n, it's 1 plus sine of n pi over 2. And we assume we have to do the same thing to find the first four terms. So a sub 1 is going to be 1 plus sine of 1 pi over 2. That means 1 plus sine of pi over 2. 1 plus sine of pi over 2. Let's remember sine, the function sine. It's 0, and then at pi over 2 it's 1, and then at pi it's 0, and at 3 pi over 2 is negative 1, and then at 2 pi it's 0, and then it repeats every 2 pi. So sine of pi over 2 it's 1, so a sub 1 is equal to 2. A sub 2, it's 1 plus sine of 2 times pi over 2, so it's 1 plus sine of pi, these two cancel, and it's 1 plus sine of pi, it's 0, so it's equal to 1. So this graph is coming in handy, right? A sub 3, it's 1 plus sine of 3 pi over 2, so it's 1 plus sine of 3 pi over 2 is negative 1, so we end up with 0. And a sub 4, the fourth term, it's 1 plus sine of 4 pi over 2, which is 1 plus sine of 2 pi, and that is equal to 1 plus sine of 2 pi is 0, which is 1. Let's see another one. Well, in this problem, again, we want to find the first four terms, but this time, the expression that is given, it's a recurrence formula. So they give me that the first term, a sub 1, it's 0, but in order to find the next term, we have to use the previous one. So basically, if n equals 1, and we replace in this expression, we have a sub 1 plus 1, which is a sub 2, is 3 times a sub 1 to the second plus 1 plus 1. Do you see how n equals 1, we replaced n here and n here and here with 1. So we get 3 times 0 to the second plus 1 plus 1, so we actually end up with 2. If n equals 2, we get a sub 3 equals 3 times a sub 2 squared plus 2 plus 1. So we end up with 3 times, now a sub 2 was found, it's 2 squared plus 3. So we end up with 4 times 3 is 12 plus 3, 15. N equals 3 is going to produce a sub 4. So we get 3 times a sub 3 squared plus 3 plus 1. 3 times, and now a sub 3, it's 15 squared plus 4. We get 3 times 225 plus 4, which is 675 plus 4, 679. So we have 4 terms, right? A sub 1, a sub 2, a sub 3, and a sub 4. Let's see another problem. The problem has a sequence 1, 3, 9, 27, 81, and the first thing that they want us to do is find the next two terms. So every time we have a sequence, it's the best thing to try to find the pattern. So I noticed that these look pretty much powers of 3, so we would have 3 to 0, 3 to 1, 3 to 2, 3 to 3, and 3 to 4. These are the ones that are given. And I'm going to write 3 to 5th, the next one, and the 3 to 6th, the next one, and so on. Now 3 to 5th is 81 times 3, so it's 243, because we are going to write them now in the form that they originally were. And 3 to 6 would be 243 times 3, so it would be 729. Now part 2 says write a recurrence formula for the sequence. So if we say a sub 0 is 3 to 0, right, or 1, a sub n would be, let's see, if this is a sub 0, a sub 1, a sub 2, a sub 3, a sub 4, we notice that these subs are identical with the exponents, right? So then a sub n would be 3 to the n. Or, I guess we kind of skipped and we found a sub n right away. We could say a sub n minus 1, a recurrence formula would be finding the, using the previous one. We can say a sub n, it's 3 times a sub n minus 1, right? In order to get the 3, we multiply the previous one by 3. To get this one, we multiply by 3, and we can say a sub 0 is equal to 1. So if I want to find a sub 1, it would be 3 times a sub 0, so it would be 3 times 1, which is 3. A sub 2 is going to be 3 times a sub 1, so it's going to be 9, which we have. So basically I can say this piece here would be the third part, and this would be the second part.